Okay, finishing up number 13b, we were just filling in our numbers for v squared. So we already had the top filled in. We were about to do cos of 22.433 minus 0.18 times the sine of 22.433. And then remember that's going to be v squared. So if you got something like 502.614, that's meters squared per second squared, take the square root, and you should get 22.419 meters per second. Okay? Alright, the last one, number 14. Now, if you did not get number 11, you might want to pause this video and try 14 again, because 14 is identical to number 11. So in 14, it gives us the mass of the car is 1,300 kilograms, traveling around a radius of 69.68 meters. Banked for a speed, so V1 is 14 meters per second. And then it wants to know what must be the force of friction if V2 is 72 kilometers or 20 meters per second. So the first step is to find your angle, and just like we did before, we had already derived it. So tan theta is equal to V squared over GR. So it's equal to 14 meters per second squared over 9.81 meters per second squared times the 69.68 meters. And I know that seems like a weird number, but it's because of the theta I was going after. If you don't round, you get 15.999. I was really aiming for 16 degrees, so I'm okay if you use 16 here. Okay? And so we're looking for friction, not mu. So this is another one where so here's my Fn, my Fnx, my Fny, my Fg, friction in the x direction, in the y direction. Okay, so you're going to start some of the forces in the y, going to be equal to 0. There's the Fny going up, the Fg going down, and friction going down. Fny is going to be, sorry you can't see the picture, it's going to be the adjacent side, so it should be cosine. Okay, so cos theta minus mg, and friction is the opposite side, so it's sine. And remember, because you're solving for friction, don't break FFR down into mu Fn. Leave it as FFR, but you're still solving for Fn in the x direction. So Fn will equal, the mg goes over and becomes positive. Friction sine theta goes over, it becomes positive. Divide by cos theta. Go to the x direction. Equal to mv squared over r. So in the x direction, fx plus friction in the x. I always leave out my n there. Sorry about that. This is fnx. Fnx is Fn cos theta. And friction in the x is, whoops, I lied. Fnx is Fn sine theta, and friction in the x is cos theta. It's the adjacent. And again, do not break it down into mu Fn because you're actually looking for friction. And now take this and sub it in where your Fn is. So mg plus friction sine theta over cos theta times sine theta plus FFR cos theta equals mv squared over r. Okay, so this is the third one we're doing like this. Exactly the same steps. Multiply everything first through by cosine to get the cos off the bottom here. So you'll still have your mg and your sine, FFR sine theta in brackets, a sine theta outside. Next term becomes FFR cos squared theta. It's a squared there. and then equals mv squared over r times cos theta. One of the most common mistakes is people forget to multiply this other side of the bracket by cosine. Now multiply through by your bracket, so it'll be mg sine theta plus friction sine squared theta plus friction cos squared theta is equal to mv squared over r times cos theta. Take this mg over, so it'll become mv squared over r cos theta minus mg sine theta. And then in these two terms, recognize there's an FFR that you can pull out, and you'll be left inside with a sine squared theta plus a cos squared theta. Best trig identity in the whole wide world. It's just 1, and so then you're left with FFR equals this. So fill in. Your mass was 1,300 kilograms. Your speed was 20 meters per second squared. Your R was 69.68 meters, and your angle was pretty much 16 degrees minus 1,300, 9.81 meters per second squared, and your angle 16 degrees. Okay, these ones are certainly easier to punch in your calculator than the ones when you're solving for mu. Assuming you can do this correctly, you should get 3,658.39 newtons. All right, done. Good job.